back at it again with one more video for you. Today we're going to break down the simulation hypothesis, or get a little bit more in depth into what we mean by the simulation hypothesis. Now, how could you ever prove that we're living in an information matrix of sorts? Well, one point of proof is randomness. Typically, if you're in a structured environment, it's not really that random. Now, try to really think in your brain, what is one thing that is truly random? It's pretty hard. There are a lot of things that seem random, but aren't. Our universe runs on a basic few laws and regulations, whether it's math, physics. Some people call math the language of the universe. 1 + 1 = 2, whether you're here on the other side of the planet or on the other side of the universe. Physics works everywhere. Now, our understanding of said physics may be limited at the time being, but physics works the same everywhere. Now, we're going to start here with this game called Game of Life by John Conway, a Harvard professor. And in his universe, it runs on these 4 basic principles. Rule 1, each cell with one or no neighbor dies, as if by solitude. Rule 2, each cell with 4 or more neighbors dies, as if by overpopulation. Rule 3, each cell with 2 or 3 neighbors survives. And Rule 4, for a space that is empty or unpopulated, each cell with 3 neighbors becomes populated. Now, these 4 simple rules creates these extremely complex forms and structures that you can see here that seem relatively random on its face, but in reality is not. Now, there are some really cool things about this. For instance, there's this one structure here. Let's zoom in a bit. Or if I do this, for instance, and I hit one of these sides, it creates these really cool patterns. And this is all formed by those 4 simple rules. Into these really cool, complex structures that form. You have to ask, are these structures what is fundamental? Or is each of these squares what is truly fundamental? It's really cool and interesting. And there's one more thing here. If I do this structure here, this is called a walker. It starts moving as if it's a little organism just moving in a diagonal. Now, does this little organism have free will? Is it a slave to the simulation? Is it a little bit of both? Or is it just a manifestation of the rules? Really interesting to think about. But this is the Game of Life by John Conway. Now, moving forward a bit, this is called the self-assembling wire experiment. And here you have this metal ring attached to a negative electrode. This is castor oil inside. These are some ball bearings suspended in the castor oil. And this is a positive electrode hanging above it. Now, nature will always follow the path of least resistance, right? So this negative wire is trying to complete the circuit, or this negative electrode is trying to complete the circuit connecting to this positive electrode using these ball bearings. And as you can see, when the experiment starts, you can see that slowly from the positive, these little arms start to form from the center, slowly moving in all directions out towards this negative area here. Kind of like a lightning strike. It's trying to find the path of least resistance to connect or complete the circuit. And once it touches the edge and completes the circuit, you'll see all the other arms die, and it starts to create this more interesting and complex structure. Now this may seem random and like, what does this have anything to do with the simulation? But in this experiment, what is more fundamental, these structures being formed or the electricity trying to flow from here to here using these structures? What is more fundamental? Do it in the opposite direction as well, where they start these ball bearings on the outside and they slowly start to move towards the center from each of these little groups. You can see they kind of look like they're alive, like they're vines growing towards the center here. And this looks like a form of life, but it's not, at least in our current understanding of physics. 22% of these ball bearings, regardless of the size, end up being at the end of these arms. 22% end up being branch points where multiple arms connect, and the rest end up being just these little connection points. So even this isn't really random. It follows specific patterns where regardless of how many ball bearings, how big this experiment ends up being, how many times you run it, 22% will always be on the end, 22% will usually be branches, and the rest will usually be connection points. Now this, when I watched this, looked remarkably similar to this, which are neurons. Now this is sped up, obviously. And if we could actually go back here and do a quick little, move that to 1.5, they look a little bit more similar now to these neurons, trying to make connections with one another. And here's a neuron up here all by its lonesome. Here you can see they're making connections and stopping these connections, these arms growing and moving in these weird complex ways. And it begs the question, what is more fundamental, the neurons or maybe electricity or information using the neurons to connect? And then here's going back to that wire experiment. Someone found a way to use the same process to solve a maze. Now earlier on, it starts moving in all these different directions equally, trying to find the best way to get from here to there, the path of least resistance. And then naturally he has to coax it a little bit because this is, a very rudimentary form of this experiment, but eventually it connects from here, going all the way down from the start point. So are these ball bearings intelligent, or is this just another form of nature following the path of least resistance? Very interesting to think about. And then here's more versions of this experiment where he's moving the positive electrode around, and you see these ball bearings are moving and shifting to try to make another circuit and make that path of least resistance. And we may consider these structures as what's fundamental. Well, we can see the structures. We can't see the electricity, but really the electricity is fundamental, and it's using the ball bearings to form to its will to create that connection. It's really interesting. And here's another experiment using slime mold. In Tokyo, their railway system was actually designed by slime mold, specifically Physarum plasmodium, this specific type of slime mold. And what it does is it moves equally in all directions, and these are little pieces of oats representing each of the stations. And they try to use this to find the most efficient path to connect all of these different stations. And they're using slime mold to do it. And slime mold, what it does is it moves again equally in all directions, and when it hits a piece of oat, it strengthens that connection between the core piece of mold and the piece of oat. And then when it connects to another one, it tries to find the path of least resistance to connect all these different pieces back to the center. And they use this to design their railway system. Now you could hire a team of dozens of designers and mathematicians to try to find the most efficient way to do this, or you could just hire some slime mold. Now the question is, obviously we wouldn't consider this intelligent, right? But is it intelligent? Because all it's doing is following the path of least resistance. And you can imagine in more complex structures, like in our modern day human society, there are different versions of this same type of experiment where these simple rules, these extremely simple rules, can manifest in very interesting and complex ways. Now, one step above this might be the game of Minecraft. And then another step above that may be our universe. But again, this is slime mode being intelligent, following the path of least resistance and what ended up being the most efficient way to connect all of their railway stations. Now it begs the question, what is intelligence really? If these wires are pretty much behaving relatively similar to neurons and how they make connections at a very small fundamental level, and you have these higher and higher and higher layers of complexity, and at one of those higher up layers you have human cognition and human intuition and thoughts and ideas. And that's all really interesting. Now that got me thinking about this as well, a quote from Nikola Tesla. If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. And what you'll see here, they have this metal plate. I'm sure you've seen this before. They put salt on this plate, and at the center they connect this to, here's a sine wave. And at the center they connect this to a speaker playing these different frequencies. They put salt on this plate here. And at different pitches and frequencies, it makes these interesting patterns using the salt. This is at 345 hertz. This is a relatively simple pattern. You may be asking, or we as humans usually ask, what's more fundamental? The pieces of salt, the overall structure, or the sound waves? What is more fundamental? And more so, how would we even interact with these manifested structures? Because if you try to reach out and touch it, you just mess with the little pieces of salt. All you can do is interact with the sound waves. And as this frequency goes higher and higher, you get more and more complex structures. Let's fast forward a bit. You get these really interesting structures here. And again, what is more fundamental? The structures, the pieces of salt, or the frequencies? Or is it all just a big manifested jumble? Like if you wanted to interact with a cloud, for instance, from the ground, you look up and see this big fluffy cloud, but the closer and closer you get to it, it just turns into smoke or mist. How would you really interact with a cloud? You fly through it with an airplane, it just kind of looks like a bunch of smoke all around you. How do you interact with these manifested structures when none of it is really fundamental? The salt is disconnected from the overall structure, which is disconnected from the patterns itself. How would you interact with these structures? Maybe you really can't, other than doing these experiments and seeing what happens. Now, this is a two-dimensional version of this, right, where the frequencies are fundamental and the pieces of salt kind of move around the whims of the frequency. But this is another experiment from the University of Tokyo, a 3D mid-air acoustic manipulation. And here, you can see this in multiple dimensions, where it's no longer just flat, it's three-dimensional. And you can imagine this is a very rudimentary version of it from 2013, of this kind of standing wave cymatic experiments. And we've seen a lot of these more recently, these standing wave cymatics where they can levitate little chopsticks now. That's kind of the length we've got to now. They take the speaker, they move this frequency against this plate, and then it bounces back, and the peaks and crests equalize. And you can catch small particles in the middle of these standing waves. And you can see these three-dimensional standing waves. You can kind of move them around and manipulate them at will. Here's a three-dimensional visualization of these waves. And here they have a piece of dry ice. And you can see the smoke conforming to these waves so you can actually see them because they're hidden otherwise. Now, why is this relevant? Well, what is matter, right? Is matter materiality, the material forming of our atoms? Is that what is fundamental? Or our atoms, are they kind of just conforming to more rudimentary energies, if you will, more rudimentary frequencies? Well, there's the concept that we're light beings. Maybe we are electromagnetic energy conforming matter around us. Maybe. But that's just a thought, and this is just part one. I'm going to come back with a few more parts to this. But I thought I'd just leave you guys with this really quick, just to consider this little guy here, this organism, just moving along its way with no idea of the fundamental rules that dictate its existence, or no idea where it's going or where it came from. It just is, just moving along, doing what it's doing, following the rules of the game of life. Really interesting. Maybe we'll play some Minecraft next time, but I'll leave you guys with this for now, and see you guys in the next one.